So we're going to work with a different kind of transformation now. This is the identity function, or just called the x function. It just means that as you go along the graph, 1 over, you go 1 up, and 2 over, 2 up. But let's look at another angle here of what all the things you can do to this information, to this graph. So here we have a more complicated version of just this down here. So this right here is the basic, just mathematical function explained simply, but this is a more complicated version of it, showing all the things you could do to this. Well, you could do more than this, but this is some basic things you could do to alter what goes on this graph. So before, we were just doing this. We were just increasing the number, and it was moving up or down. So 2, 3. But now that's it going up and down. I know that it's going to look like it's doing the same thing, and I'll show you in a moment how it's different. But we can move left and right along this graph by changing the number right here. And what you're going to notice is, and this is a good way to show this, because when this goes up by 1, it's going to move left. I know it looks like it moves up, and your intuition is if this goes up by 1, it should go over that way. But it actually does exactly the opposite and goes over that way, because you're altering how much work the x is doing by itself, and it's easing off to go that way. So let me show you. If I go by 1, it goes 1 to the left. If I go 2, it goes 2 to the left. Now, it kind of looks like it's going up, but it's not. Now let me show you in the next graph, the x squared graph, how you can see this better. So right here we're looking at the x squared graph, and we went over this before. We're going over 1 squared is 1, 2 squared is 4, 3 squared is 9. And we want to look at all the things we can do to manipulate and transform this graph. So on the top here we have this setup where these are the various things you can do to this graph to change its appearance. Before, like I said, we did this, moving it up and then back down the graph. But now we want to look at moving it left to right. And it's counterintuitive that we're going to add one number here, but it's going to go that way. And it works even for negative. Now, I know that this is going to seem a little complicated because there's a plus sign here. So it's x plus 0, and then it was x plus 1 to move it to the left. But we're going to do, and this is just the way the computer program is set up, if we hit -1, this really should just read, but it keeps the plus sign there, so you know that this normally would be adding something, but you're adding a negative. So this would read, if this wasn't here, x minus 1. So when it's x, ignore the plus sign, -1, it moves to the right. -2 moves even more. So here's the benefit of doing this. Let's suppose we want to get this bottom piece right here, the very bottom point, down here, right in that area right there, which looks like 3 down, 4 over. So it's so it's on the x-axis +4, -3. Knowing our transformations up here, we can go 4 will get us, or let's do it a different way. Let's say we want to get it up here. Keep all positives. So we won't mess with negatives yet. We'll go all positive right now. 4 on the x and 3 up. Before, we know we can go 3 up just by going up 3 there. So this elevated along the y. And then this right here will get us over 4, but not with a positive, with a negative. So that's the position we're in right there. So you may be saying, what can we do with these transformations? What is the practical use of moving the information around and applying it to some other area on the graph? Well, I'm going to show you. Let's suppose that these white dots are some data that you have, some information that you have. And you want to fit this curve in the best way that you can over and in between that information. Now this could be anything. This can be like maybe the speed of a vehicle and how much damage is done to the vehicle. That could be like financial cost, or that could be the force of it hitting something. And we want to fit this graph in between that information. Well, let's just start with what we know, what we've done before. We can move it up, say it's about 3 up. And again, to move it to the right, we have to put a negative number in here. And it seems counterintuitive, like you think like a negative would go that way, but this is, in this situation, when it's in these parentheses set against this x with a plus inside, if this becomes a negative number, it'll go to the right, and if it's a positive number, it'll go to the left. So it looks like I want to have it right here, which is about, let's try 3. We'll just do 3. Oh, again, I made the mistake, negative 3. So now I want to flatten it out. This is too tight. I want to get it. Now what I don't want to do is this. I don't want to just say, well, we can move it down and then we can move it over, and that's kind of close. We want to try and get it as best as we can, so we'll go with negative 3 and 3. And we want to flatten this out here so that this line will end up right in here. Let's go to, let's say 0.5. That's not quite enough. Let's go to 0.2. There we're a little closer. I think maybe 0.25. And the only thing we might be able to do is move it over to the right slightly, because these are kind of far off. They're touching too much here and not enough here. So if I want to move it to the right, let's go negative 3.3. And then maybe just slightly steeper now at 0.27. And that seems to be the best fit that we can find for all that information. Now how we use this is the full equation of what we would use. But we would only want it to apply from above about, this looks like 3.7, to about 8.5. This is the only applicable area on the x-axis. Everything else is not pertinent because we don't really have data for that. It could go on upward in that direction, but we're not sure. For now, this is all that we know.